Today on How It's Made. Fresh cut flowers, combining nature and nurture. Adhesive tape. We'll stick to the facts on this one. Tofu. Making the bland grand. And lottery tickets. Sometimes a winner, but always a gamble. To wish condolences, congratulations, or for romance, there's no shortage of customary occasions on which to send flowers. Whether made up in a splendid arrangement or simply placed in a vase, fresh-cut flowers rarely go unappreciated by the recipient. Roses are a perennial favorite. Florists buy them from commercial greenhouses. Those greenhouses have sophisticated sprinkler systems positioned to irrigate the soil rather than the plants, because watering directly on the rose bushes would grow harmful fungus. The hotter the weather, the more watering, up to 7 times daily for about 5 minutes each time. The greenhouse climate is computer-controlled. If it gets too humid, the computer automatically triggers the roof to open, bringing down the temperature. The ideal greenhouse temperature for most flowers is about 23 degrees Celsius during the daytime and 16 degrees at night. With every watering, the roses get a low-level dose of fertilizer, the botanical version of taking a daily vitamin supplement. It's a mix of nitrogen, phosphate, and potassium, the proportions determined by ongoing soil analysis. If the pest specialist detects a bug problem, he applies an insecticide treatment to target that particular pest. But first, they close the roof so as not to pollute the outside environment. Workers handling the chemicals wear masks and protective clothing. The roses grow through the openings of horizontal trellises positioned one above the other. This ensures the stems grow tall and straight. Crooked roses, after all, are worthless. Cutting the roses is tricky and prickly. Workers have to wear thick gloves to protect against the thorns. They cut the stem at a 30 to 45 degree angle just above the second set of 5 leaves. The cut must be precisely at that spot for a second rose to bloom, about 40 to 55 days later, depending on the season. Growth is slower in the winter because there's less sun. The growth period also varies somewhat according to the variety of rose. The fresh-cut roses go into a bucket of lukewarm water with a few drops of bleach to kill off any harmful bacteria. Workers then check each and every rose to make sure the blooms and foliage are free of defects. Then they classify the roses by length. The longer the stem, the more the rose is worth. They make a bundle of each length. Then trim the bottom of the stems to equalize the height. They wrap the roses in newsprint so they won't dry out during shipping. The transport trucks are refrigerated in summer and heated in winter to keep the roses at a safe temperature, about 6 degrees Celsius. To make a bouquet of dried roses, they select open blooms for a nicer look, then hang them upside down in a room cooled by fans. They leave lots of space between bouquets so the air will better circulate. The roses take a week to dry out. Fresh-cut flowers are striking, whether part of an arrangement or in a vase. They can last in water for about a week, provided you trim a centimeter off the stems to open up the water channels, fill the vase with lukewarm water, never cold water, pour in a bit of bleach to ward off stem clogging bacteria, change the water every 3 days, and be sure to keep the flowers away from the heat of a sunny window. Adhesive tape was invented in 1925 as a painter's masking tape for auto body shops. That led to transparent tape, designed to seal the cellophane wrap used by the food industry. Then tape was introduced as a household item, and the idea just stuck. These rolls of plastic film, called polypropylene, are on their way to becoming shipping tape. The rolls go on a machine called the unwinder. Workers then position a strip of adhesive splicing tape along the end of each roll. This will enable them to connect one roll after another, creating an uninterrupted feed to the production line. Now watch closely. Once a roll unwinds completely, its end sticks onto the splicing tape at the beginning of the next roll. Once that roll's unwound, its end will stick to the beginning of the next, and so on. An automatic tension adjuster ensures that the machine pulls the film evenly to prevent ripping. The unwinder also applies a solvent to the film surface. This prevents the film from sticking while unrolling. To transform this film into tape, they coat one side with a hot adhesive known as hot melt, made from several ingredients. Synthetic rubber gives it flexibility. A UV protector keeps it from drying and discoloring, while an antioxidant prevents aging. Synthetic resin makes it sticky, while pigmentation oil provides a choice of colors, in this case, tan. They load the hot melt into a preheated holding tank, which maintains it at a piping 200 degrees Celsius to keep it from hardening. The tank pumps the adhesive to a machine called the gluer. They wipe away the excess, then roll the film. And there goes the adhesive. A cooling roller, that black one on the top, immediately hardens it. A computerized sensor ensures there's an even coat of adhesive. If not, it automatically signals the pump to adjust the output. Now, a machine called the rewinder rolls the tape onto spools. Remember the unwinder that spliced the rolls together? Well, the rewinder unsplices them. When a spool fills, a knife separates the tape at the splice point so that winding can begin on the next spool. The tape on just one of these spools would run the length of 85 football fields. The spools feed a row of sharp razor blades called the slitters, which divide the 1.5 meter wide tape into several strips. Shipping tape is 48 millimeters wide, so they get 31 strips per spool. Each strip winds onto a cardboard core, its end sealed with a tab. The length of tape per roll varies according to the customer's specifications. As the machine ejects the finished tape rolls, in comes the next batch of cardboard cores. Then it's off to the packaging department. Nothing's shipped out, however, before a quality control check. They test a sample roll from each spool. In one test, they unroll the tape sticky side up, then release a tiny stainless steel ball down an incline. measuring how far the ball rolls before it sticks and comes to a stop. To pass the test, the ball has to adhere within a certain distance. The stopping distance varies depending on the type of adhesive tape. Some people just can't get past that rubbery texture, but tofu enthusiasts say it's all in how you prepare it. Tofu is a great source of protein, low in saturated fat and cholesterol-free, and it's versatile, absorbing whatever flavors surround it. Tofu is made from soybeans, the seeds that grow in the pods of the soybean plant. They contain 40% protein, more than double the protein in beef or fish. They start by soaking the soybeans in cold water for 18 to 24 hours, depending on the season. In winter, beans are stored in outdoor silos and take time to warm to room temperature. Here's what the beans look like before and after soaking. As they absorb the water, they double in size and soften up a bit. The bloated soybeans go onto a conveyor belt, where a rotating device transports them to a crushing machine. The machine crushes them into a thick and grainy soup of soybean milk and pulp. It does this by forcing the beans through a filtering screen. Next, they transform the soup into a paste by heating it in a steam cooker for 3 to 4 minutes. Then it's into a centrifuge machine. As the chamber spins, the centrifugal force separates the milk and pulp. The milk passes through a cone-shaped filter, while the pulp, called soy meal, sticks to the sides of the chamber. The soy meal goes off to be sold for cattle and pet food. The milk stays behind to be transformed into tofu. Still piping hot, it goes into a coagulation tank to be thickened into curd. But first, they add different herbs and spices, because this batch will be sold as flavored tofu. Then they add the coagulant, magnesium chloride, along with water to activate it. Then more stirring. It takes about 15 minutes for the soybean milk to congeal into soybean curd, otherwise known as tofu. When it's ready, it's still steaming, but pretty soggy. So they run it through a perforated cylinder to drain as much liquid as possible. By the time the tofu comes out the other end of the cylinder, it's relatively dry and roughly the consistency of scrambled eggs. Now it can be processed into those familiar blocks you buy at the supermarket. They transfer the tofu into large rectangular molds lined with cheesecloth. Then it's into a press that applies 59 kilograms of pressure. This squeezes out most of the remaining liquid and molds the lumpy, loose tofu into a firm rectangular block measuring 38 by 74 centimeters. They cut the block lengthwise and widthwise into 54 blocks of 300 grams each. Tofu itself is pretty tasteless, but like a sponge, it absorbs the flavor of whatever it comes into contact with. They drench this batch in a spicy marinade to make jalapeno-flavored tofu. After verifying the weight of each block, they package the tofu with a sprinkle of spices for garnish. Then, to kill off any bacteria, the blocks go into a pasteurizer at 110 degrees Celsius for an hour. When they come out, they drop into a cooling basin, into water just above freezing temperature. They stay submerged for about an hour. Tofu comes either pre-flavored or plain. It also comes in different textures. Firm tofu maintains its shape in soups and stir-fries, while soft tofu and silken tofu are ideal for blended dishes and desserts. The odds of winning big in a lottery are slim, to say the least. Still, we keep hoping that lottery ticket will become our one-way ticket to extreme wealth. Experts say your odds of picking the winning numbers never change, no matter how many people buy tickets. Lotteries are by no means a modern invention. The emperors of ancient Rome held them for entertainment. European monarchs used state lotteries to help fund their extravagant lifestyles. And the American colonies held lotteries to finance roadwork and construction projects. Pressure from the church and widespread fraud led many countries to ban lotteries during the 1800s. But governments eventually reconsidered. They just couldn't resist milking that cash cow. Those eye-catching tickets are designed by graphic artists. A technician takes the design, separates it by color, then sends the information to a machine called an image setter, which generates one negative per color. Next, they place the appropriate colored film under each negative and expose it to ultraviolet light. This hardens the color not shielded by the dark portions of the negative. When they wash away the unhardened color, they're left with a color image. They layer the films to make the client a mock-up of the finished lottery ticket, in this case, a scratch-and-win type. Now they make the printing plates, one for each color of the design. First, for the non-playing area, everything outside the scratch zone. Each negative goes onto a paper-thin aluminum plate coated with a UV-sensitive emulsion. They expose the plate to UV light for about 20 seconds. This hardens the unshielded emulsion. The rest is washed away in a chemical bath, leaving the design in relief on the plate. For the ticket's playing area, the same process, but instead of an aluminum plate coated in emulsion, they use one made of photopolymer, a light-sensitive plastic. The finished plates are now ready to go onto the printing press. Their raised surface will work just like a rubber ink stamp. The non-playing area goes on first. This method is called offset printing. The press applies up to 9 different colors, one after another, from lightest to darkest. High-intensity UV lights dry the ink in the mere half-second between color applications. Next comes the playing area. A high-speed inkjet printer first applies the game numbers, chosen randomly by computer. Infrared lamps dry the ink in a split second. A strobe light enables the press operator to do spot checks as the tickets whiz by at a rate of 5 meters per second. Then the printer gives each ticket a unique barcode. This enables ticket vendors to scan your ticket to see if you've won. It also shows whether a winning ticket is genuine or a forgery. The next machine seals the game numbers with layers of varnish, then applies 6 coats of scratchable ink. An electronic scanner checks the positioning of the scratchable ink, making sure it hides the numbers. The first 3 scratchable ink coats are black, the next 3 white. All those layers to keep cheaters from holding the card up to the light to see the numbers. Now they can finally print the playing area design onto that white background. In this case, a crossword design. A machine now perforates the rolls of tickets so they can be folded. It processes 3 meters of tickets per second. Here's what that looks like in slow motion. The next machine folds the tickets along the perforation lines into piles called fan folders. Goodbye slow motion. Here's the actual speed. Before the lottery tickets are shipped out, several samples undergo a quality control inspection. The company checks that the tickets are properly printed, and it performs a series of scratch tests and chemical tests to make sure they're absolutely cheat-proof. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.